One of the questions that I get asked a lot from customers is what drives the need for the radii that we talked about in the stamping video. If you haven't seen the stamping video, go see that. But one of the things in compound dies is we have to have a corner radius. So one of the questions I get is, A, why do we have to have a corner radius? Maybe you can speak to that a little more. And then if I want to minimize that, is there an advantage, a disadvantage, and obviously is there a cost to lessening that radius in the corner?
Yeah, so with a compound tool, we like to hold a minimum of 7 thousandths external corner radius. This is partly due to the diameter wire we typically run in the wire EDM machine, and also to improve the longevity of the die. A larger corner radius is going to break down a lot slower compared to a smaller, sharper corner, especially when you get into cutting nickel and cobalt-based steels. We can go with a tighter radius. We can get down to about 5 thousandths with the compound tools, but to do that, we need to switch to a smaller diameter wire, and that in turn, we have to run everything slower and take additional passes to get the accuracy of the geometry we're trying to cut. So it increases the cost of manufacturing the die, and it'll also, the tool won't last as long in between sharpenings with the smaller corner radii.
So basically it's physics, much like anything metal. If you're familiar with metalworking, anything with a sharp corner, the sharp corner is going to be your failure point. Anything with less than a sharp corner, you get increasing strength as you increase that arc.
Yep.
Like the aqueducts. I get it. So can you get sharp corners on the features in a lamination? Say I want my teeth to be sharp corners, or I want sharp corners in the back of the slots because I'm trying to pack square wire into this thing. Is that a possibility with a compound tool at all?
So with the compound tool, no. We would be looking at a progressive tool at that point for the sharp corners, because with a progressive tool you can overcut and undercut and end up with sharp geometry that you wouldn't be able to in a compound tool.
So from a length of time, a lead time, and a cost perspective, if I wanted sharp corners on a feature, let's say the end of fingers, my slot openings, is that another station, another 2 stations in the die?
It all depends on the geometry of the part, but you would be splitting that work from 1 station like we would do in a compound tool into 2 or 3 stations in a progressive. You would cut the slots in 1 station and then in the next one, and in the station you're cutting the slots, your punches would extend past the outer periphery of the part, and then in one of the following stations you would just cut that outside geometry. So you're
basically going to cut the geometry and then come across it like that.
Yeah, you would overcut and then just cut the diameter of the part as you would normally.
So this is a station. This is a station. Does that apply to each feature then? If you wanted sharps in multiple places.
Yeah.
So what Derek's saying is the more of those that are critical to your component, the more stations you're going to need. Is it doable? Is it achievable? Yes. Is it critical? Is up to you. If it's critical, we'll have it produced. But what you should look at first, is it economical? Is a 5 thousandths to 7 thousandths radius worth 1 to 2 to 3 more stations of a tool where you're talking 2.5, 3.5, 4x the tooling cost? Is it that critical? And a lot of engineers, you guys know this better than I do, when it comes down to it, and you look at that, you can do something to modify your calculations so that you can get the proper amount of wire, the proper amount of coverage in there, and not necessarily need that sharp corner. So look at those sharp corners. It'll come as a deviation. If you send a print in and I send you a print from a customer, all the corners are sharp, you're going to give us feedback in sales or in estimating what?
That if we wanted to accomplish this with a compound tool, that we would need a 7/1000 minimum corner radius on all sharp corners.
So it won't be something that just an estimator's telling you. It won't be something that comes from sales department or myself. It's going to be something that's driven by engineering and the experts based on our capabilities. If you want to give us feedback on a deviation form and say, hey, Steve, I need this. Tell me you need that and it's necessary for your process. We'll come back, we'll reevaluate, we'll tell you what it takes. So either way, compound tool, progressive tool, we can get it done, but a full 99, 95% is a very high percentage of my customers in aerospace, defense, critical applications, space components, commercial, doesn't matter. Most of those customers will err to the side of a compound tool, save a little bit of money. The other thing that I get asked a lot is, what is the difference in longevity? So is this compound a soft tool or is this a real tooling? What's the longevity difference? What's the difference in the materials?
It's the same materials we would use in a progressive die. They're all heat-treated tool steels. Some of the not so critical non-cutting components we'll use A2 or other tool steels.
Why not carbide?
So carbide is more expensive, and it's trickier to work with.
It's also, would you say it's a little more brittle when you get into those 5/1000ths radius and those sharp corners?
Yeah, it can definitely chip a little bit easier. It's not as resistant to shock.
I get asked this a lot also. Why not carbide? Carbide's the best. Old school, and look at me, I'm old school. Carbide is the best. Carbide is the sharpest. Carbide is got to be cut with diamond. It's got to be great. Not necessarily. Sometimes that, like Derek said, that toughness, that brittleness will work against you. If you've ever dropped a piece of carbide and had it crack in the last stages of getting the tool finished or something, you know, oh my God, now I start over. It's the same thing in the die. It may or may not have the longevity that you think it has when you've got that constant pounding action and you're running that die in high production doing hundreds of thousands or millions of parts. Our tools will, correct me if I'm wrong, but our tools hold up to the same longevity as carbide does. We still produce somewhere between 2 and 3 million parts out of a compound tool. It is not a soft tool, and it is not something we just throw together. There's a lot of engineering, the same amount of engineering that goes into this.